Hello and welcome to Application Testing with Studio Pro. In this demo, we'll cover database testing. This is a way to start testing early, since the data model and the database are typically set up before the UI and even before the API. We'll start with a project that fetches data from a database, then we'll see how a basic test case can be created, starting from the workflow. Later on, in the next demo, we'll get to see data-driven testing for databases. This is UiBank Studio Pro, our IDE incorporating RPA development, test automation for both RPA and applications, as well as other advanced capabilities. It shares many functionalities with UiBank Studio, starting with the way projects are being built, by dragging and dropping activities. Activities are grouped in packages, each of them covering a certain technology or application. Some of them are pre-installed, but many of them have to be added by the developer. In our demo today, we'll be using the database activities. This is a package that needs to be installed manually. Here's how we do it. Open Manage Packages. Go to the All tab, search for the keyword, in our case database, then hit Install. Once the package is installed, we will see the activities in a subfolder under App Integration. Let's quickly touch on the main function of each of them. The connect and disconnect activities can be used to connect to a database and consequently disconnect, as well as perform any desired actions with individual connections. Execute non-query is used to execute SQL statements on the database, like update, insert, or delete. Next, execute query is used for select statements. Insert gives us the number of records affected when we insert values into the database. Finally, start transaction is a cohesive set of activities. It connects to the database at the start and disconnects at the end. Inside it, we can add other database activities. Basically, it works like a scope activity. Now let's take a look at the database. It's a SQL database called UiBank Accounts Database. It contains the account number, the bank code, the account type, the opening date, the name of the account holder, and the account balance. Let's go back to Studio Pro to see how to work with such a database. What you see here is a rather simple workflow built beforehand. It consists of a start transaction, which connects to the database, and a query to fetch the account details based on the account number. Let's take a closer look. The start transaction activity can be configured with a connection string variable, or using the connection wizard. The wizard allows us to select the database type, which can be one of the common ones: Access, ODBC, or SQL, or it can be of type other. We'll obviously go for SQL Server and confirm. Then input the server and select the authentication type. In our case, it's Windows Authentication. Next, we'll select the name of the database from the drop-down list. Let's click Test Connection to see if it works. It's successful. Before moving on, notice the connection string generated here. We'll get to it right away, but let's first select SQL Client from this drop-down. Okay, so here in the Properties panel, under Output, we can save the database connection in a variable or an argument and use it in other activities. And let's do exactly that. It's time to check the actual query. We're using the execute query activity. The database connection variable is added here to connect to the database we've seen. And here's how we could have added it in a new activity. Let's now take a moment to understand the select statement. What it does is identify a database record based on the account number, and return all the details for the record found. The account number value is received from the input argument at the end of the statement. This is our simple sequence. We'll now make a test case out of it. The easiest way is to right-click it in the project panel and select Create Test Case. Let's give it a name. The test case is now created in a given when-then structure, also known as the behavior-driven development structure. Given is used for the initialization of variables and initial configurations. Our initial workflow is being invoked in the when block. Finally, in the then section, verifications are performed. To see how these should be used, let's check a test case we built a bit earlier. The given block is empty. The when block contains the workflow we've seen, and the then consists of 4 verifications. The first one is meant to check if the record exists in the database, and if it is unique, this is done using the count method applied to the output, and the result should be 1, otherwise the record doesn't exist or is not unique. The second verification deals with the account type. It checks the output in a given column against a static value, which is savings. Similarly, the third verification is on the name of the account owner. The value used for the verification is once again static. Finally, the fourth verification checks the account balance. Before executing the test case, let's quickly check the ways we can create custom verification messages. Each verify activity has these two fields: alternative verification title and output message format. Whatever we add in the alternative verification title will be displayed in Orchestrator when we publish and run it from there. Otherwise, it will use the title of the activity from the test case. In the output message format field, we're making the customizations. Here's where we can use 4 standard values taken from the verification activities. These are left expression, right expression, operation, and result. Our custom message goes like this: verification of actual record count equals left expression. Then we're using the operator from the verification activity. Then the right expression is the expected value. And finally, the result. This can be true or false. The second verification activity doesn't have a custom output message, so it will be a good chance to notice the differences between the two, and the value added by investing some time on customizing the output messages. We're now ready to run the test case. It's done. Let's open the output panel. Notice the difference between the output messages, with the first one being customized to improve readability, and the other 3 standard, taken as such from the activities executed and their outcomes. We've reached the end of our demo. We've seen a simple project executing a query to a database, then we've turned it into a test case and executed it. In the next video we'll keep the context, but advance to data-driven testing. Stay tuned.